Welcome to Attributions. In today's episode, we speak with Davide Faranda about a recent study he and other scientists conducted on the attribution of climate change on the heat waves that affected Central Asia last year. We also speak about some of the science behind heat waves, the impacts that heat waves are having in the region, and of course many other interesting topics. Davide is a senior scientist in climate science at the French National Centre for Scientific Research, and his main expertise lies in attributing extreme weather events to climate change. Since 2017, he's also been an external researcher at the London Mathematical Laboratory and at the Dynamic Meteorology Laboratory of ENS in Paris. In France, Davide is coordinating a team of 30 researchers working on aspects linked to weather and climate extremes. He's also authored over 100 scientific publications and has written a scientific book. Last year, in 2023, Davide launched Climometer. It's an international platform for linking extreme weather events to climate change immediately after they occur. It was wonderful speaking with Davide, and I hope you enjoy the conversation. Okay, we are here with Davide Faranda. Davide, thank you for coming on Attributions.
Thank you for inviting me.
So today I just wanted to dig into some research you've done with your colleagues on temperature rise in Central Asia. But first, I'm just wondering if you can give us a brief background on who you are, what your research looks into, and anything else that you think is important.
Yeah, sure. So I'm a physicist by training. And then I studied climatology. And I did my PhD in Hamburg and in England, in Reading, near to London. And I started to work on extreme values, but from a more mathematical point of view. And that was the background for me then to apply this mathematical skill to the study of weather extreme events. And starting from 2015, I was at CNRS in France. CNRS is the National Center for Scientific Research. It covers all the discipline, and my task was basically to work on climate change and climate change for extreme events. And at CNRS, I'm coordinating a group of about 30 researchers who work on these topics from different angles, for example, statistics, applied mathematics. My focus now is attribution. Attribution means finding the role of anthropogenic climate change in the occurrence or in the change of intensity over a specific extreme event. So I think that's what we will cover during this interview.
Yeah, no, I think it's a good place to start with a bit of a geography lesson, so to speak, because I think Central Asia is not as widely known as, its South Asian or East Asian counterparts like India and China, for example. So I was just wondering if you could give us a quick kind of tour of what countries we are in fact talking about, and of course what drew your attention to research in this area on this particular project that you worked on.
Yeah, perhaps I start from the end of your question. So the idea of studying the rise of temperature in this area is to cover an area that is not really covered by other studies, especially attribution studies. Attribution studies focus now more on the areas where there are attribution groups. So even our Climometer, and we will go into the details later on, it covers mostly Europe and US and other countries where we have scientists working with. So we have decided to commit to cover also countries that are not studied from the point of view of the impacts of climate change. And therefore, Central Asia is really an area that is interesting to cover because the geography of this area. So just to give you an idea, we are talking about the countries that are, we can take the center in Afghanistan, and then we have to the north the Turkmenistan, to the south the Pakistan, and to the south also the Iran. So these areas are basically uncovered by climate studies, and they are interesting from a geographical point of view because there is a lot of agriculture going on geography that is kind of complex. We have the presence of lakes, we have the presence of mountains, and we have also some desert area. The thing is, with climate change, this desert area can extend. The area is subject both to the influence of monsoon, but also the influence of the mid-latitude weather. So what we call like extratropical cyclones and anticyclone. It is an area that is interesting to study for many reasons, but especially for the social and economical reason that climate change can trigger on this population, because rise in extreme events, rising temperature can be very damaging for a population that is based on agriculture and highly vulnerable to change in the seasonal cycle of temperature.
Yeah, no, I mean, I've traveled through Central Asia myself, and I can definitely attest to, the fact that, as you said, the landscapes are so diverse. You have these huge mountains, massive glaciers, you have big lakes, you have these grass fields, and then you have your deserts, and so it is a pretty interesting area. And I think that it's good that the research is getting attention there. So and I think if we look back, the study was focused on last year, so 2023, and I think last year was quite extraordinary, when we look back at what we saw happen across the Northern Hemisphere during the summer, the summer period, where, we had heat records being broken from, Vietnam to the United States to Europe, all over the place was getting, it was essentially boiling. So I'm just wondering, was Central, like in this period, I know the study focuses on winter, but in this period, do you have anything to say, did Central Asia also experience, these unprecedented heat waves, over their summer, or was it largely spared?
Well, we had basically extreme weather all over the Northern Hemisphere for the entire summer. So there were heat waves also in China, in Japan, and these heat waves were simultaneous with heat waves in Europe and in the US. So basically, this was somehow something unprecedented in some sense. We had it also in 2022, but in 2023, this was way more intense. And as you said, well, even at the global level, we reached this 1.5 degrees temperature anomaly, which is kind of the security threshold discussed by the COP. And that is, well, we are living in this world that is warmer, and we see the effect of extreme events all over the world. Now it's we had also the South America, Chile fires. We had many events also in South America, also in Australia. So it's really a global problem. And before we were seeing these extreme events popping up here and there. Now, together with the colleagues of the World Weather Attribution, that is another group performing rapid attribution studies, we have a report of the triggers of extreme events. And every week we have multi-triggers, so we have many extreme events at the same time. What happened with respect to the previous year, just to give an idea of what's going on, it's in fact the ocean is getting much warmer, especially the Atlantic Ocean. And this is problematic because the ocean has is a big mass and a big thermal inertia, so it can drive extreme events, extreme heat waves also on land once the air masses move towards the continent. So we don't know if this extreme warming of the Atlantic combined also with the El Nino, that is the phenomenon that occurs in the Pacific, will go back to some warming that is normal or what is expected with this level of CO2 concentration, because also the phases of the ocean can be influenced by climate change. So this is a big landscape we are moving in, where there is a lot of science that is yet unknown.
David, you mentioned the term, thermal inertia, and I know I'm deviating a little bit from our topic, but I just think that if you could explain to listeners what you mean by thermal inertia for people who don't know what ocean thermal inertia is.
Sure. This was a bit technical, but the example will be much easier. So, we have a viscosity in fluids, so the air is very volatile. Then if we take honey, that's very viscous. And in fact, and the water is something in between, right? So these different properties, the way the molecules in fluids join together, give also the properties of keeping temperature for a longer time. So if we have a bath and we put hot water and then we leave it cool down, we can take our bath after 20 minutes, even half an hour, it will still be warm. But if we put warm air in a room and then we open the window, this is immediately mixed, and then we have to turn on the heating again if it's cold. So that's the concept of thermal inertia. It means that the water or the honey can store heat for a longer time. So if the ocean is warmer, but then it can produce, it can exchange with the atmosphere this heat and then produce extreme events for an entire season or for an entire year, depending on how warm it is.
Yeah, no, that's it's very interesting. And also now just coming back to Central Asia, I think that your study looked at the winter period in Central Asia last year. So, when I was in Central Asia, I was there in winter, and I can remember how cold it gets, in the region, and sometimes in the minus 40 degrees Celsius in some areas, right? How much warmer was last year's winter in Central Asia compared to, say, a regular kind of average year?
Yeah, in fact, it was way warmer because of the lack of snow. So it depends on the area that we are considering. Also in our study, we see that for the specific extreme events, we have area where the change in temperatures are zero or even negative, and area where it's way warmer. And to explain this, we have to go back to the geography once again. So the important thing to understand is that in these continental areas that are very far from the ocean, in winter, what is important to reach like negative temperatures or to have cold is the presence of snow on the ground. We have seen it in Canada. We have seen it also in Siberia, in the southern part. In the last year, we have basically lack of snow, or the snow comes, but then it melts after a few days, after a few weeks. And when there is a surface covered by snow, we have what we call in climatology albedo effect, which means that the snow can radiate energy to the space very efficiently, and so cool down the surface a lot. This is, not so good for the population that lives there because they can reach like a very low temperature, but it's good for the ecosystem and is good for preserving the snowpack. And the snowpack is essential then in spring and in summer to have a water reservoir that is what you need then to do agriculture. So that's the general landscape. And what happened in Central Asia in the last year, in the last winter, it was this lack of snow, this dry condition that prevent the accumulation of snow on the continental area. And therefore, we don't have the presence of these cold air masses sticking to the ground. We have relatively warm air masses, and when there is wind from the south, we can reach very high temperature, as we have seen in this event that we have covered.
Would you say that, I know, with an albedo as well, when you talk about the snow reflecting, sunlight back into space, I think without the snow as well, would it be safe to say that the surface of the Earth is actually absorbing more heat because it is darker at that period as well, which is kind of creating a positive feedback loop, which, it gets warmer and then the snow melts and then more snow falls, but it gets warmer and it, keeps on going, basically?
Yeah. This is definitely a feedback mechanism that exists in this region, and there are also other feedback mechanisms that can be for this region, as we've seen for Canada, dangerous. For example, the lack of snow, the soil is dry, and then even in winter we can have fires, and then this fire propagates. They destroy part of the snowpack, so this is not compact anymore, and then we have these feedback effects that can be sustained for an entire year, or like in Canada, we have seen these going from the winter to the next winter before a big blizzard came in and could stop the fire. So there are many feedbacks in the climate system, and the one you mentioned is definitely very important in this case.
Now, if we talk about a temperature figure in Central Asia, how much warmer was it compared to an average year? Was it 1 degree warmer, 2 degrees warmer? What did you guys find?
Well, it was way more than that. We had over the entire area. That is what I was saying before, and so Iran, Afghanistan, and then the northern part of our study was basically Russia already. We had over all this huge area that is about 20 degrees in longitude and latitude. We had plus 10 degrees anomaly, a minimum plus 5 degrees anomaly. So, and this was basically for an entire week. So huge temperature anomalies. Well, when we have winter, hot weather, hot extremes, this doesn't really impact the population immediately. Actually, we almost enjoy, because we have this sort of spring weather in winter, and who doesn't like that? But what it really does, it perturbs a lot all the vegetation, all the snow reservoir, and also the animals that are lost in their landscape. They don't find the elements that they are used to, and for the vegetation is even worse, because we can have blossoming, we can have a complete change in the phenological cycle, the cycle of the plants. And when that happens, if then, for example, we have snow, we can completely destroy the fruits that are growing in the wrong season. So basically, this temperature anomalies over this huge area was definitely impactful for all these reasons.
Now, talking about, I think we're sticking on the topic of impacts. I think you've just mentioned some, very kind of big short-term impacts that we've seen there, that you've talked about, for example, like the immediate effect on, say, biodiversity, the immediate effect on, plants and the flowering, and kind of how that, impacts also agriculture. But I'd just like to kind of get your sense of what you think would happen if something like, these 5 degree to 10 degree, anomalies, as you've called them. What if that happened over consecutive number of years? What would be the kind of long-term impact that you would kind of expect to see?
Well, yes, these are very interesting questions. I remember that this area is not well studied, but we can draw analogs with other areas that have been studied and that have similar characteristics. If you have this impact on several years, these anomalies, what the impacts will be mostly on the hydrological cycle, so the water. Probably what will happen is that some rivers will not flow anymore, or you will have very scarce water, and this then will impact agriculture, but also in general the vegetal life. And some species, when you don't have enough water or you have too warm temperature, you cannot grow them anymore. So what this population should do then is to change, for example, species, if they can, start to grow something else. This is already happening in many regions of the world. For example, me, I'm Sicilian. Sicily is an island in the center of the Mediterranean. And before we were growing aubergine and also oranges, lemons. And now, due to climate change, we switched to mangoes, bananas. So completely different fruits, tropical fruits. So for this area, it will be a little bit different. Perhaps they could grow then this kind of aubergine and summer vegetables, while now they have a completely different agriculture. But it can be even more destructive than that if these temperature anomalies persist over several years in several seasons. Then they can start a drought, agricultural drought. And the drought is really problematic on these scales, the scale of several countries, because it means that you don't have water for agriculture, but also water for energy production sometimes. And then prices, what happens on the population, because then we are interested in the impacts on the population, but then prices rise because there is a scarce abundance of food. This happened in Europe, right? Like last year, because of the drought, the price of the olive oil in Spain multiplied by 2 to 4. So it's something that these populations that have not great income in terms of national but also personal income, they can be really in trouble if this happens. And this can trigger also then social and political instabilities that in this region are also one key factor, because there are different countries with different cultures and also unstable borders sometimes. So we can imagine that if some country is more concerned than others, then there could be also some what we forecast in the IPCC report, that is some migration, but also some war for the resources, and the resource will be water, basically.
Yeah, I think one thing that I was thinking of when you were mentioning, people adapting and growing different crops, it also depends on, how many resources those people have to shift into a new, agricultural system. I mean, for many countries, like you said, they don't have the money to do it much of the time. And then, of course, when you have consecutive drought as well, shifting to a new crop becomes, even harder, because the environmental conditions aren't, ideal. You don't have an ideal income situation either. And then, yeah, I think that you do walk down that path of, a very kind of shaky social, system where things are being very challenging for the local community. So I think an important thing here you mentioned in the study as well, and this kind of ties into what we were just talking about, is you mentioned adaptive strategies. So I'm just wondering if you're able to expand on that, and I know you did just talk about some solutions, but I guess what would be, in an ideal world, what would you see? What would you want to see happening?
Well, in an ideal world, we have to keep low the CO2 emissions, and we have to avoid to go into a global warming that is above 2-3 degrees. Because we've seen that already in the studies, this is relative to the 1979. So it's not even the beginning of the global warming. And we already see that with the global warming go to 1.4, 1.5 degrees, we get anomalies of 10 degrees and changes up to plus 5 degrees with respect to the period starting in 1979. And therefore, this, we cannot adapt everything when the temperature gets too warm. So talking about dreams, what I would like to see is a global engagement to really reduce the CO2 emissions, because what we see in Climameter is that extreme events are already so intense right now, and it's just scaring to see what could happen in the future with +3 or +4 degrees of warming. But anyway, if we have to think to adaptation, I think that the most important resource, I say it once again, is water. So even the governments with low income, they should focus on water storage to have reservoir that could be used in the summer season to keep doing agriculture above all other things. And every country should start to think really to become independent from this point of view, because we have seen that, and this is it's not something that I can say as a scientist, but as a citizen of this world, and that unfortunately the global political situation is not really stabilizing. So this solidarity, this United Nation dream for the moment is something that we have, of course, to pursue, but we also to prepare for the other scenarios. And so I think that everywhere adaptation should focus on producing or storing the resources such as water, energy locally. And we have these renewable energies such as solar panels or windmills that are not so costly, even for low-income population. They are diffuse, so they can produce energy on diffuse networks. They don't need big infrastructure. And they are not targets from a military point of view, like a carbon power plant or a nuclear power plant. They become target. We've seen this in Ukraine. Instead, wind farms are so beautiful. You cannot destroy all of them at once. Solar panels, same. And you can produce them everywhere. So also in the adaptation strategy, I think that there should be a huge part of renewable energy that is also the basic for not producing any more CO2 emissions with the traditional form of energy, such as burning fossil fuel.
Davide, I'm just curious. You mentioned talking about preserving, water resources, for example, and adapting to warmer temperatures. I mean, I'm just curious if you've heard of the artificial glaciers that are happening in India, in the Ladakh region.
Yes, but I mean, this is also something that goes. It's a bit. It's debated what the effect can be of these kind of things. It makes me think of also what happened in Switzerland, where to save the touristic season for the ski, the Swiss government authorized to take part of a glacier and displace it to produce snow for the people to ski. I mean, artificial glaciers, yes, I mean they can help to have some water storage, but they are very costly in terms of also CO2 emissions. So basically you have to think to that trade-off when you do an adaptation strategies, but then the adaptation strategy is also producing CO2 emission because you have to cover the glacier, you have to make it grow and so on. Then it's in the long run it will be counterproductive, I think. So
because the artificial glacier that I'm talking about is because I've seen it during the winter time up there, and they basically have a bunch of hoses that push water up into like a fountain, and it kind of just freezes, consistently over the winter. And then I'm not entirely sure how long that will last when the weather heats up, obviously.
And
as you
also
said,
the question.
As you said,
the water. So
exactly,
the water will be pushed by fossil fuels. So
if you're using a diesel engine to generate the power to push the water, then it kind of defeats the purpose. I get that. And of course, if the region is warming up too quickly, then obviously the ice will melt very, very quickly. So
one aspect that I forgot to mention before I had it in my mind was also the fact that when we adapt for a climate that is continuously changing, we don't know what we have to adapt for at the end, because we don't have a final state where the temperature of the Earth is stabilized, right? So also these agricultural adaptation strategies that we can have, such as changing cultures and vegetables to grow. They are. We go in the darkness. We don't know where we go because we don't know what will be the final stabilized temperature of this planet. If there are no the famous tipping points that we are tipping points, so means that we can change completely the climate of the Earth, like for example by melting all the permafrost in the Siberia, or by destroying the Amazon forest, changing the circulation of the ocean. So there are many of these things that if we warm too much the planet, can trigger regional changes that are not way stronger than the one we analyzed in Climameter, and in that case, I think that we will be in trouble all, and there will be not really adaptation strategies that can fast adaptation strategies that can save us, and we will go through big changes.
Yeah, I think I think adaptation is an important concept, but I also think that it shouldn't distract away from, the main cause of the problem in the first place. And, I hear what you're saying in terms of, we don't know what could happen, and adapting to, something unknown is almost impossible when you don't have enough data, if the data isn't showing, it's showing a complete picture, right? So on that note, Davide, I know we're coming up to our time limit. So I just want to, again, thank you for your time and expertise and sharing your thoughts on these really important matters. And I think that, the work that you're doing is very important, and it's good to see that, areas like Central Asia are getting a bit of attention, where, as opposed to, as you said, they generally fall off the radar of many people's research. So before you go, Davide, I'm just wondering if you could point listeners to anywhere that they can follow you or look at more of your research, or maybe even the study in Central Asia that we've been talking about.
Yeah, so we have this platform that is a platform for rapid attribution studies that we have launched in July, and we've already covered 40 extreme events. It's Climameter, so you can follow us on X, the X Twitter. The hashtag is Climameter again, so it's very easy to find. Or you can follow us also on the website www.climameter.org. And personally, you can follow me on my Twitter page as well. Or on LinkedIn, you will find, of course, my contact. And also, we are happy to exchange with the public. If you have ideas, if you have questions, suggestions, please let us know, and we will be very happy to answer, and also to cover extreme events, to perform rapid attribution studies of extreme events that happen in your region.
Awesome work, Davide. Thank you so much for coming on. I really appreciate it.
Thank you very much for the very interesting conversation.
If you found this episode of Attributions valuable, please don't forget to subscribe to our podcast channel, follow us on social media, share it with your friends and with your network, and visit our website at www.climateimpactstracker.com for articles and more. Thanks again for listening, and I'll see you again on the next episode of Attributions.